Hello guys, today we'll be starting February March 2025 mechanics. So let's begin. Session work, yeah. Three coplanar forces of magnitude 40, 30 Newton and x Newton act on a point in the directions shown in the diagram. Given that the forces are in equilibrium, find the values of theta and x. Okay, so we can apply Lami's theorem because there were three forces, but I am pretty sure that is not possible because we do not have this angle. Yeah, so we can't really apply. We'll go for um, the normal method. That becomes this and this x cos theta, x sin theta. And given that it's in equilibrium, so and the second one should be and if we substitute that, that would become 30 is equals to 40 and sine over cos becomes tan theta. So 3 by 4 tan theta equals to 3 by 4, and if we take the inverse, that should give us about 36.86. 3 significant or 1 decimal place 36.9. And if we need to find cos, so we can just use the same value of, and x would become 40 over cos of answer, that is 50. This is exactly 50 newtons. A cyclist is traveling along a straight horizontal road at a speed of 4 meters per second. When she passes through a point O, and then she accelerates for a constant distance. Constant rate for distance 42 meters, reaching speed v. Then she maintains that speed for 50 meters and then decelerates at 2 meters per second square before coming to rest. The distance traveled while decelerating is if we take u is equals to v is 0 and a as negative 2 meters per second and s 16 meters, so that should 2s v is 0, that cancels out, the v square minus, and that becomes 2 into minus 2 into 16, so that is 2 into 2 into 16, which is minus 64. Minus minus cancels out, and if we take the root of 64, that becomes 8 meters per second. So we had to go in reverse order. Find the total time for which she is in motion from the instant she passes O. So basically the total time. So we know that So we know for a fact that we started off with 4, that should be u is equals to 4. Then she accelerated to v, and v is 8. And in order to find the time, we u plus at, we do not have the acceleration though. If we want to find, so v is this, s is equals to and 42. So first of all we need to find the acceleration, then using that acceleration we find the time. And that should become uh, 2 as equals to v square minus u square, and we know 2s, so the v is 64 minus 16, and that should be divided by 2 into s is 42. Yeah, 42. That is acceleration, and the acceleration is minus 16 divided by 2 into 42. Four by 7. Using that we can find or we can just use v is equals to u plus 80. I think that would be much better. So v is 8. 8 minus 4 divided by 4 by 7. That is 7 seconds. 8 minus 4 divided by 4 by 7. T, the t is 7. So initially, so for the first part of the journey we have 7 seconds. For the second part of the journey we should have either traveling at a constant speed 50 meters, so t should be equal to 50 divided by 8. That is about 6.25 seconds. This is for stage 2 of the journey. And for the deceleration part we shall use, we have the acceleration, so we can use v is u plus 80, v is 0, and u is minus 8. Come on that side, so minus 8 is equals to minus 2 t, and t is equals to 4. So the total time would be 4 plus 6.25 plus 7, that is 17.25 seconds. The total time the total time would be 6.25 plus 4, that is 17.25 seconds. The airplane is flying at a constant speed. The airplane is flying horizontally. Aeroplane. The airplane engines are producing a constant power of 5500 kilowatts, and the aeroplane is a constant horizontal resistance for the 2500. So we have this, and as it's a constant power, and it's flying at a constant speed, so okay, so forward should be equal to backward, as resultant force is 0. So forward force is equal to backward force, as resultant force is 0. Therefore the forward force should be 25,000 Newton as well. And power is FV, and 5500, both are in kilos, right? So we can just ignore the kilos and find out the speed. That is 220. So 220 meters per second. Part 2. The airplane then ascends 300 meter, ascends as in like, yeah. While maintaining the same speed, the resistance force is no longer constant, and the work done against resistance force in ascending the 300 meter is this. The mass of the airplane is this. Find the average power. Okay. So the speed is same, and it ascends 300 meters in this given time period, and the resistance force is no constant, and the work done against it. Okay, so if this is the aeroplane, it ascended like this, and this is 300 meters that we are talking about. So 300 meters is mass is this. Apparently, if we are using mgh, so the time taken to rise this and the same speed, the work done against the resistance in ascending is 2070. This if we take it like driving force equals to gain in gravitational potential energy plus work done against resistive forces, that is 60,000. So gain in gravitational potential energy would be 60,000 mgh, right? So into 10 into 300 plus work done against resistive forces. Actually, this is not driving force, this is work done. So work done would be F D somewhat. Yeah. So, and we are not aware of the or F V, but that would become power. It has to be FT. Plus work done against resistive forces, which is 270,008 kilo, an additional 0. This is our work done against the resistive force in ascending the, yeah, So, and that works. So this becomes what exactly 60,000 into 10 into 300. This becomes 180. If I can write in exponents, 180 exponent 6 plus 270, 1, 2, 3, 4, 5, 6. 270 exponent 6 joules. This is the work done by the, which is basically equivalent to FD. And we know we have time though. So yeah, what is power? Power is work done per time, FD over T. So we have the cumulative sum of 180 exponent 6 plus 270 exponent 6, and that divides by 50. So we are getting 9,000 kilowatts. 9,000 exponent 3, which is 9,000 kilowatts. Yeah, that should be it. Two particles have masses 0.3 and 0.1 respectively. The particles are attached to the ends of the light inextensible string. The string passes over a fixed smooth pulley and the particles hang vertically below the pulley. Both particles are initially at a height of x meters above ground. See the system. The system is released from rest. So the tension, so this would go down, this would go up. So here it would be a resultant force. We will have two equations that would be, or if we are considering the whole system, we cancel out the tension, but we have to find the tension. So 3 minus T is equals to 0.3A, and T minus 1 is equals to 0.1A. If I eliminate them, that should become, by adding, that becomes 2 is equal to 0.4A, and we get acceleration as 5 meters per second. And applying that, 5 into 0.1 plus 1, so we have T as 1.5. So tension is 5 into 0.1 plus 1, that is equals to 1.5 newtons. During the subsequent motion, B does not reach the pulley. Okay. B does not reach the pulley. Chen is asked. In Barbie, during the subsequent motion, X does not. So, does not find the greatest height. So we know that this would move down same distance, this would move up the same distance. Now at this point, after traveling the same distance upwards, the wire would slacken, it would continue to move for a short period of time, then come momentarily at rest, and then it would fall backwards. So one equation we can form is that we know S is equals to X, and A is 5 meter per second square, and V is unknown, U is 0, T is unknown as well, so we can use 2as v square minus u square. 2as is equals to v square minus u square. V is unknown, so we take v square. U is 0, so no 5 into 10, 10x. So equation 1 is this, and second equation we can use is that that would be from here. We know that this total distance is 2x. We know the speed at which it, the point it reached the ground, the speed would be the same as b. Meaning the speed of a at the point it reached ground would be same for speed of b when it, the moment before the wire became slack, because they are both going up and down with the same acceleration and traveling the same distance. So that would become v is 10x root. U is unknown. Actually, no. Shouldn't be U. Shouldn't be V was 0 though, because V is the final, and U should be 10x. Yeah. And so yeah, if this is like 10x and it goes up, it's momentarily 0, so s should be 1.2 minus 2x, because this total height is 1.2 and a is minus 10, so it should be 2as v square, that's 0, and minus u square, which is 10x minus, and 2a is 20 into 1.2 minus 2x minus 10x, minus cancels out, that becomes 1 by 2 x, 1.2 minus 2x, that becomes 2 plus 1 by 2, 2.5, 0.5x, and 1.2 divided by 2.5, 0.48. X is equals to 0.48 meters. Particles P, Q, and R of mass, these are in a straight line on a smooth horizontal plane. The distance between P to Q is 3 meters. The distance between Q to R is also 3 meters, and P is projected directly towards Q with speed 3 meters per second. After P and Q collide, P continues to move in the same direction with speed 1.5 meters per second. So I think we are supposed to apply principle of conservation of momentum. So speed 3, so 3 into 0.6 plus 0 is equals to P continues to move in the same direction. So if that goes there, that would be 0.6 into 1.5 plus 0.4 V. So 3 into 0.6 is 1.8. 0.6 into 1.5, that is 0.9 plus 0.4. 1.8 minus 0.9 divided by 0.4, that is 2.25. So V is equals to 2.25 meters per second. It's faster than P, makes sense. In a subsequent collision between P, Q, and R, these particles coalesce and find the speed of the combined particle after this collision. So Q and R collide. R is stationary. Rest, yeah. So 0.4 into 2.2. Now this would probably rebound. No. Yeah. So this from this and this from this and then this collides. Okay. I'd rather bring it forward. Excuse me with 2.25. So 0.4 into 2.25 plus 0 should be equal to 0.4 plus 0.8 is 1.2 V. 0.4 into 2.25 divided by 1.2, that's 0.75. So V, actually V is already used, so I'll probably take this as S. S is equals to 0.75 meters per second. How much are we left with though? Okay. Find the time it takes for when particle P is potential project until the instant at which P. Okay. So basically, we break it into stages. So stage 1, so T1 would be when the time taken for P to collide with Q. It was initially projected with speed of 3 meters per second. That would become 1 second. So this took 1 second. Now T2 would be when Q collided with R. Q was traveling with 2.25. Yeah. So 3 divided by 2.25, that is 4 by 3 seconds. In the same time period, P would have also traveled a certain distance in the 4 by 3 second time period, because it was also moving with speed of 1.5. So we'll find out S, the distance traveled by P in those 4 by 3 seconds. That would be 1.5 into 4 by 3, which is equals to 2 meters. And now we know that it has traveled 2 meters, meaning the distance between P and the combined particle QR is 1 meters. And if we explain it in a larger scale, QR P, the distance is 1 meters. So if we were to form an equation, it would be S is equals to x plus 1. X is the distance they would further travel to and at which they would collide, and for that would be S is equals to x, and A is 0 for both scenarios. Both are moving with constant speed. V is unknown. U is 1.5 and that is 0.75. And time is the thing that we are going to find. So x plus 1 is equals to ut, which is 1.5t, and x is equals to 0.75t. If we equate both, so that would become 0.75t so that would become 0. 1.75 t plus 1 is equals to 1.5 t. So 1 is equals to 0.75 t and t is equals to 4 by 3. So in total 1 second, 4 by 3 second and 4 by 3 seconds. So total time would be 1 plus 4 by 3 plus 4 by 3. That should become 11 by 3 seconds or 0. Or 3.67. 3 significant. A block of mass 12 kg is placed on a rough plane inclined at an angle of alpha to the horizontal, where alpha is equals to tan inverse of 0.5. Alpha is equal to tan inverse. So tan theta, tan alpha would be 0.5. That is 1 by 2. So it would be somewhat similar to alpha. So tan alpha 1 by 2. 1, 2, 2 to 4, 5 root of 5. Okay. A force of x Newton is applied to the block directly up the plane. Okay. The coefficient of friction between the block and the plane is mu. It is given that mu is 0.15 and x is 20 newtons. Find the time that it takes for the block to move 2 meters down the plane. Down the plane from rest. Interesting. So, okay. Before I begin, just need to be sure that 2 square plus 1 square is 5 and 5 root 5, 5 root 5, right? So, sine alpha would be equal to 1 by root 5 and cos alpha would be equal to 2 by root 5, right? So, then we would be requiring this here in order to calculate normal contact force. That would be 120. So R should be equal to 120 cos alpha. Cos alpha is 2 by root 5. So 120 into 2 by root 5, that's 48 root 5, and with that we can find 0.15 multiplied by this. So our frictional force acting on the block is, so F is equals to mu R and 16.099 newtons, which would be acting here, 16.09. And if I write 120 sine alpha, that is 1 over root 5, that is about 53.66. 53.66, and x is 20, so 36.09 would be the backward force. 36.099. So backward force is equal to 36.099 newton, and the forward force, which is the parallel component of weight, alone is 53.66, meaning we can calculate the acceleration. That is, resultant force is equals to ma. Resultant force is 53.665 minus 36.099 is equals to 12a. So 53.66 minus 36.00099, that is 17.56, and divided by 12, that becomes 1.4638. We can use v is equals to u. No, we don't have v though. We have s. So 2 meters, ut, u is 0. So half into a into t square. So that is 4 divided by acceleration, that is this, and we take the root of it, so we get t as 1.653 or 1.65 seconds. 1.65 seconds. 6 marks. Wow, damn. It is given that mu is no longer equal to 0.15 and that when x is equals to 10, the block is on the point of moving down the plane. So the surface is changed, I guess. Moving down means that the forward force equals to b. It's in limiting equilibrium. Find the value of mu and the value of x for which the block is on the point of moving up the plane. Moving up the plane. That is down the plane and moving up the plane. So it would be greater than x though, for sure. So the frictional force acting, so no, the parallel component would remain 53 point what? 53.665. So 53.665 is now equal to F plus X, where F is the frictional force, so X is 10. So 53.665 minus 10, that is 53.665 minus 10, that would be 43.665. 43.665. Right. And we know that F is equals to mu r, and r is 48 root 5. So 48 root 5. So 40 answer by 48 root of 5, that is 0.40. So mu is 0.40 now. 0.4068, which is 0.407. They're asking to find the value of mu, that is done, and the value of x for which the block is on the point of moving up the plane. In order for the block to move up the plane, the frictional force would remain the same, and the weight component would be considered against. So it would be like, so x should be sum of F plus the parallel component of weight, that is 43.665 plus 53.665. So 43.665 plus 53.665, that is about 97.33. That is 97.33, and I'll just leave it as 97.3 newtons. Next question. A particle moves in a straight line. How many questions are we left though? Okay, we're done. Last question. A particle moves in a straight line. The velocity v meters per second of the particle after t seconds after leaving a fixed point is O. Given fixed point O is given by the equation, okay, where k and p are constants. The acceleration of the particle at t1 is this, and the displacement from the particle at t0, what t1 is 93 meters. Show that k is equals to 3 and p is equals to 26. K is equals to 2. So they have given us particles. Right, so k is equals to 3 and um hmm, hmm. So k is a constant. Um, if I expand the equation, so um if I derivate it into acceleration, so this goes out, all constants 0. That would become kp, and this would become 6 to the 12 kt. Your acceleration at t1 is 42. So 42 is equals to kp minus 12k. This is our equation 1. And the displacement, for displacement we have to integrate it. So s would be 20 kt plus kpt square divided by 2 minus, that would become 3 and 3 cube, and 3 6 divided by 3 is 2, so 2 kt cube. And at 0 seconds there is 0 displacement, so I'm not writing c. And at t1 we know it's 93. So 93 is equals to 20k plus kp over 2 and minus 2k. I can substitute kp with 42 plus 12k, substitute that there and get value of k. 93 is equals to 20k plus 42 over 2 plus 12 over 2k minus 2k. So that should become 20k plus 6k minus 2k plus 21. So 26, 24 and 93 minus 21, 72. 72 divided by 24, that's 3. So k is 3. That's proven. And 3p is equals to 12, 44, 36k. 36, my bad. K is substituted 12, 36. And 36 plus 42 divided by 3. And p is 26. That's proven. So we can now write our equation as v is equals to 3 into 20 plus p is 26t minus 60 square. That would become 3 to the 6, 60t, 60 plus 26 threes are 78 t. 6 threes are 18 t square. This is a final velocity equation. Find the distance moved by a particle between the time at which its acceleration is 0 and the time at which its velocity is 0. Acceleration is 0, 78 minus 60. I think that is 36, yeah. So, and acceleration being 0, that becomes 0. So 36t is equals to 78. 78 divided by 36, that's 13 by 6. Between the time when acceleration is 0 and the time at which its velocity is. So this is when a was 0 and acceleration, or when velocity is 0, that would become so like we would do like okay, let's solve, then we'll see. So okay, so when velocity is 0, so this would become 18t square minus 78t minus 60 is equals to 0. And if we solve it simultaneously, if we solve it using the midterm break method, I'd rather use quadratic formula. So we are getting two values of t, that is one is 5 and the second one is minus 2 by 3, and this is rejected. So our time bracket would be distance traveled between 5 greater than t and 13 by 6. 13 by 6 should be like, isn't 13 by 6 2-ish something? Yeah, so it's the other way around. It's 13 by 6 and 5. So displacement would be s is equals to 60t plus 78t square, 78 divided by 2, 39t square, and 18 divided by 3 is minus 6t cube. At s0, t0, s0, integrate this with respect to the limits, that is 5 over 13 by 6. So we will be getting 5 6 are 300 plus 39 into 25, that is 975, minus 525, 125 into 6, that is minus 750, minus 60 into 13 by 6, that is 130, plus 39 into square of 13 by 6, 13 by 6, that is 183.083 minus the cube 6t cube, that's 6 minus 61.027. So 300 plus 975 plus minus 750, That becomes 525, and this would become 130 plus 183.083 minus 61.027. That becomes 252.06. 252.056 and 272.944. 272.944, which is equal to 273 meters, and the paper's complete. Yeah. Thanks for watching. Bye.